Hello guys, my name is Unku, and me and my group will present a study on statics. So what study? Let's check it out. Hey you! Have you seen any black hand truck around?
Do you mean that truck?
Yeah, that one. Can you hold the truck for me? So now we move forward to our analysis. This right here is what we will analyze today. We will use methods like free body diagram, equilibrium principles, and moment of inertia. So we will use a hand truck, a box of mineral water, a weighing scale, measuring tape, and of course a calculator. Wow! So first we look at the external force. We make several assumptions so that we assume that the trolley is at rest. So for internal force, we will separate the hand truck into several members, and for moment of inertia, we will actually focus on the tire. After I ask the guy to hold the trolley, this is what happens next.
Thanks, Uncle. Hi, I'm Shafika. With me here is two of my friends. Hi, I'm Noor. I'm Noor. We would like to explain about how to calculate forces. Here is a picture where my friend lifting up a hand truck to move a box. From all the information that we have, we can calculate forces. First and foremost, we need to draw a free body diagram to analyze the system, which can be resolved in X and Y component. There is vertical force applied at handle 8 and the reaction force at the wheels. Remember that there are assumptions to be made. Mass of the truck is smaller compared to the box, hence it is negligible. We can calculate forces of the hand truck at rest, hence all the forces are in equilibrium. And remember, we have two wheels of this hand truck, hence the reaction force will be distributed evenly. So we can calculate vertical force at A by assuming moment at point D is in equilibrium. First, we can calculate the weight of the box by using the formula W equals to mg, where m is the mass of the box and g is the gravitational acceleration, a constant with value 9.81 meter per second. Then we multiply the force with its perpendicular distance to D and let it equals to 0 as the moment is in equilibrium. We assume the counterclockwise rotation as positive, then we get this equation. Then we solve the equation and voila, we get AY equals to negative 16.1 Newton. Because AY is a force, negative means it's in different direction of the original y. So in this case, it is downward. Then after we get applied force at A, we can calculate the reaction force at the wheels. Remember that we have two wheels on the hand truck, so we would have two same value of reaction force as we assume that the force is distributed evenly. Because wheels are considered as a roller, the reaction force is in y direction pointing upward. We total up all the force in y direction equals to 0 and we can get this equation. When we solve the equation, we get reaction at each wheels equals to 72.8 Newton. The answer is positive, so the direction is the same as the original, which is upward. Now I pass to Jocelyn to continue.
Thank you, Shafika. Hi everyone, I'm Jocelyn. So these are not the only forces present in the hand truck. There are still other internal forces present in each member of the hand truck. So, as an example, we calculate all the forces in member B, C, D. All the three members of the hand truck are separated as shown in the diagram below. So, the analysis of frame method is used in this case. After some analysis, it is determined that the forces present at member BCD are forces Bx, By, C, D, and W, which is the weight, sine 28 degrees. So first of all, the distance of x and y are calculated using the sine formula. So for x, we get 32.4 cm, as for y, we get 42.1 cm. So since the entire system is in equilibrium, the total moment at point B is equals to 0. So by using this principle, force C is calculated and the answer we get is negative 93 Newton. So the negative sign of force C indicates that its actual direction is opposite to its assumed direction. So next, force Bx and By are calculated using the equilibrium principle. So the total forces at component x and component y is equals to 0. So by using this formula, Bx and By are calculated, and for Bx we get negative 66.4 Newton and for By we get 64.3 Newton. So the negative sign for Bx indicates that its direction is opposite to the assumed direction. So this is similar as force C. So these are the magnitude and direction for all forces in member B, C, D. Through this calculation, it is proven that there are internal forces present in each member of the hand shaft. That's all from me. Thank you. So now I'll pass it to Arvin.
Thanks, Jocelyn. So let's analyze the moment of inertia at the hand shaft. But I want to explain. No, I'll explain. Please. Hi. Okay, carry on. Yay! So let's begin. This is the unloaded hand shaft, and this with load. Now let's zoom to the wheels. Here you go. So I'm gonna explain to you about the calculations involved in the moment of inertia at the wheel, which can be explained by taking its circular shape as so. Hey, hold on. Do you even know what the moment of inertia is? What? Of course I do. Hey, then explain to us what's about. Sorry, my bad. The moment of inertia is actually the quantity that determines the torque needed for the desired angular acceleration about a rotational axis. Could you simplify that a little? Okay. Do you know Newton's second law of motion? Yeah, F equals ma. Yep. That is used for linear motion, meaning the force and acceleration will be in a straight line. Comparatively, this involves the rotation, as mass determines the force needed for a desired acceleration here. The moment inertia determines the torque, which is the rotational force needed for a desired angular acceleration. Nice one. Let's move to the calculations now. Firstly, the radius of the circle is 7.25 cm. It'll look like this, the axis, and its area is obtained from pi r squared. Later, find the moment of inertia with respect to the x prime axis at the center of the circle as shown using the given formula. Then we shift it to the actual x-axis above using the given formula as well, where d is the change in distance, which in this case is the radius. Then we could find the radius of gyration with the information obtained and also the centroidal polar moment of inertia. Wow, that was some explanation you've got there, bro. Let me top that off by saying that calculating the moment of inertia in this case is essential for us, commonly engineers, to know the effectiveness of the hand truck's wheels in turning and transporting the load. Thank you.
Okay, now we will proceed on the conclusion part of our study.
To sum it up, knowledge of various methods of analysis is important in the engineering field,
especially in constructing objects and structures in daily life.
This analysis can be done to evaluate the function, safety, and limitation of a structure.
For instance, the correct determination of forces in the free body diagram may assist in the usage and further modifications of a structure.
Equilibrium and moment of inertia analysis may also be used to retrieve information on the strength and sturdiness of a structure.
This info can help in the manufacturing process to obtain the desired end product for the benefit of all.
That's all from us. Thank you.